Although O.J. Simpson wasn't his jury, didn't they? Wasn't there quite a few females on his jury? I think so. I wonder what happened there.
I was actually in Los Angeles with
I wonder if someday he'll write like some memoirs about like what really happened.
He tried to. They stopped it.
Why? Because he admitted to it or something?
Yeah, his book was named How I Got Away with It.
Right.
And no one would publish it or anything, so they just stopped it.
I mean, there's some evidence of like a great attorney. When you bring in a team of attorneys that, I mean, his DNA was on gloves and stuff. They found his blood at the scene. There's video showing him killing her.
yeah.
It wasn't me.
The glove man doesn't fit.
It doesn't fit.
Oh. But think about how many times they've used that the pun from that in TV shows and stuff like that. Seinfeld, they had the lawyer Jackie.
Greatest character.
Yeah, well, I mean, yeah, that's right, the greatest character. You know, and he was the, he was basically what was the guy's name? He passed away now. Not Clarence Thomas. That's a Supreme Court judge guy.
Yeah.
But you know what I'm talking about.
I do.
Yeah.
I can't remember.
You turn this fine specimen into a horrible, twisted freak. The man's a goblin.
There's somebody who posted a picture like on the internet. It was just like greatest license plate of the '90s, and it just says OJ did it.
You know what? I bet he didn't do it.
And the culprit just planted his blood.
It wouldn't have been so easy. I mean, if I'm somebody who was going to do something like that, wouldn't it be easy to take the spotlight off of me to just frame a celebrity? Seems like it would be. So, like, obviously, I would frame, like, who would I frame? This is on the record.
Obama.
No. You could just.
That would be pointless.
All right. So let's talk about our second. Wonder what this last page is all about.
Oh, what is that last page? It's the key.
Who is it? How do I rotate it? Tools. Rotate left. Okay. So I think we have our aiming one completely working, correct? After we've done the translation. So next one is this thing called start line. So we're going to hit 10 putts from 18 inches through a 2-inch wicket. Isn't that like what they call the thing in not rugby, cricket? They call it the wicket.
It's a wicket.
That's a dumb sport.
Yes.
Do you know in India, it's not uncommon to see people playing cricket on the streets with keyboards as the I guess that they call it the bat.
The paddle.
Is it the paddle?
I think it's called.
Well, they call them the batsman. When the person's up, that's the batsman. So it seems like the batsman would carry a bat. Why are you sitting over there today?
That's been brought up like 5 times.
You're throwing it off, man. You're throwing it off.
Once again, cord.
What are you doing with a power cord?
Well, it took him about 10 minutes to find the outlet, so.
Well, you didn't know what they looked like. Cut them some slack. Okay. So we're going to hit 10 putts from 18 inches, so relatively short putt. Okay, so this is a 1.5 putt. And we're going to hit the ball through a 2-inch wicket, so a very small space that's barely wide enough for the ball to go through. We're going to place a 1 if we make it, or a 0 if we miss it. And I'm thinking this isn't whether or not you make the putt or miss the putt, but whether or not we're able to hit it through. We're not putting to a cup, we're putting to this 2-inch wicket thingy, okay? So 1 if we get it through, 0 if we don't. So we're going to have our which is funny here, because they say place a 1 if you make it or a 0 if you miss, yet they have a bunch of negative 1s here.
This is a great
These
example.
instructions are just great.
Great example of what not to do.
Okay, so our handicap, let's see, 1, 2, 3, 4, 5, 6. So we had 6 makes. Minus 4 for misses. So 6. So how do they get minus 2?
Because you add 4 to 6.
Well, yeah, but so if we have 6 and we add negative 4 to that, we have positive 2. Don't we? It's kind of amazing how inaccurate this is, but the fact they actually put it into a document.
With no key or explanation.
All right, so what's this one going to be? Well, I guess we can go and figure it out. We can figure out the numbers after the fact, but let's think about how we'd implement this. So we're going to have a start line object that will feed an array into, and the array, at the very least, we can just keep track of misses and makes, right? We can decide how we're going to interpret those mathematically later. Actually, does minus 2 even fall onto the handicap scale? Okay, there's minus 2. Let's work backwards. Let's say he made them all. So that would be plus 10 here. And so their final number seems to make sense. Somebody who's making 6 out of 10 of these seems like that's a top amateur. So I'm thinking that's an accurate number. So I believe in that number. So hold on. Start line handicap. This is their overall handicap. So this is a cumulative number. Does that make sense? This is a cumulative number. So based on minus 6 and 4. So minus 6 plus positive 4 is a negative 2. Okay, so it seems like they completely discount misses here. So misses are ignored. And what they do is just add up all the ones you make and multiply it by negative 1. And that gives you your start line handicap, the specific handicap for this thing. Does that make sense? So that means if this guy made 6 out of 10, they're saying he's a amateur. So that's his start line handicap. So his aiming handicap was a 4, which puts him at tour. So aiming plus start line, he's currently at top amateur between those two. I think that makes sense. We interpreted that correctly? Okay, so we need to read in an array, and this array is going to have the number of, well, for our 10 putts, they're going to have 1 or 0. I don't know why they're doing this negative 1 thing. Go ahead.
Let's say you made like 9. So would that switch to, you put it to negative 9?
Mm-hmm.
But then
That'd be worse.
Yeah. No, that's an excellent point. Actually. Yeah, so what the heck? Yeah, the more he makes, the worse he gets. Okay, so multiplying by -1 isn't what they're doing. So how are they coming out to -6? It's like an algebra thing. Go ahead.
With the misses, they're just minusing that -10 or something. Because if you take off the -4, you get like -6.
Oh, so they're forgetting about the makes. They're ignoring the makes and subtracting out of 10 putts. So 10 being the best you can do, they're subtracting 4 to get us to a -6. So that means if we made 9, we would subtract 1 to get to a -8, which would then still be worse. Yeah. Once again, what was this guy on?
I'm just going to say documentation. Clear documentation.
So made 6 out of 10. Yet we have a start line handicap of -6, which is a amateur. Which actually seems weird because there's a lot more levels in here than there are putts that he missed. Two-inch wicket. Place a 1 if you make it, or a 0 if you miss. This really seems like it should be top college. So we're taking the 6. We're adding to it -4, which gets us a 2. So is it possible that this is wrong?
It's possible everything's wrong.
Well, let's look at the next one. Let's see if this one makes some sense. We can write the data structure and I can ask for some clarity on this. Short putting. Hit 1 putt from each direction in length. Place a 1 if you make it, or a, oh, this is going to be good, or a 0R if you miss it to the right, or a 0L if you miss it to the left. Okay, so we're going to hit it from 3 feet, 4 feet, 5 feet, 6 feet, and 9 feet. 1 if we make it. So so not only are we hitting this distance, we're also hitting a left to right putt, an uphill putt, a downhill putt, and a right to left putt. So in this case, they made 4 of them. This is for our left to right putt, and missed 1 to the right. This one, they made 1 of them, missed 2 to the right, 2 to the left. Made 3 of them, missed 2 to the left. Made 3 of them, missed 1 to the right, 1 to the left. Okay, so they came up with a short putting handicap. How did they come up with that? Is it just the ones added up? Well, this might be just informational, whether or not there's a pattern as to how they're missing. You know, if they're always missing putts to the left, on a, you know, let's say it's a right to left putt and they're always missing it to the left, that might be something with alignment, since they're consistently missing it on that side of the cup. It could also be they're reading too much break or something like that. But I see what you're saying is, as far as this goes, as far as calculating these numbers, the handicap seems to ignore misses in this case. So we're just adding up. But the information for missing right or left might still be useful because that's probably going to get stored someplace. So when we store it, later on we might query it and see how they've improved. Do they have less misses to the left, less misses to the right, that kind of stuff. Okay, so this one seems to just add up their total number of makes across all these things to give them a handicap. That seems to be pretty correct, right? And if they made more, they'd have a higher handicap, which is better. And if they made less, they'd have a lower handicap. How would they get to a negative handicap? So let's say they made 0. Oh, hold on, there's a scale. Is there a scale up here? There's a scale up here. What? This changes everything. Hold on. So much clearer. Well, sort of. Only sort of. Why? Because he made 6 of these, right?
Yeah, so 6 out of 10 is equal to negative
6 out of 10 is equal to -2. But this is saying that's his overall handicap.
Yeah,
This is start line handicap. Start line handicap is -6.
Is it by? Well, that can be by misses because
Well, misses. He missed 4 out of 10. Would put him at a -6.
if you miss 10 out of 10, you get a perfect score.
Yeah. So with that in mind, maybe we just say this is wrong. Because we can always come back and update this. Yes is a 1, 0 is a no, yet we have 1s and -1s. This is going to be a really funny conversation when I talk to this guy. All right. For now, let's assume that this number is off, which therefore makes this number off. So if he has a 4 up here, overall handicap is a 4, and this one should be a -2 because he made 6 out of 10. That means he should currently be at a 2, which puts him at a top college. That feels correct to me for somebody who had pretty good aiming and not horrible start line. I mean, 6 out of 10 isn't terrible. It's not like you're hitting the tees every single time. That feels correct to me. So I think that we can make the assumption right now that start line handicap was miscalculated here. Okay? So we're going to read in an array of our 10 putts with a 1 where we make them and a 0 when we don't make them. Let's just, because it seems like this -1 means nothing. Okay? Then from there, we're going to add up the makes, and we're going to have to implement it on this scoring table to give us our handicap. Okay? So, we'll implement this as an array. How would we implement our scoring table? This is another example of probably parallel arrays. Okay? So, let's go and let's make a start line object. Okay, so start line, we're going to have a constructor that's going to take an array of integers as a parameter called putts. Is there a reason to store those putts long term? Or are we really just calculating handicap? I think maybe we just have a private int handicap. Okay, so we're going to create our parallel arrays for our chart first. Okay, so we're going to have a integer array called the handicaps. And this guy is going to be equal to all of our handicaps from our chart. So 4, 4, 2, 0. -2, -4, -6, -8. -10, 12, 14. Okay, so those are our handicaps. Then we need to have our breakdown of how many putts we made. So 10, 9 all the way through 0. In array makes okay. So if they have 10 makes, there are 4. They have 9 makes, there are 4. They have 8 makes, there are 2. So there's our parallel array thing. Okay. Now we need to count the number of makes they have inside of putts. So we need to go through and add up all of our putts. If putts only takes in ones and zeros like their text says it should, we should be able to literally go through and just sum up putts. Correct? 1 plus 1 plus 1 plus 0 is correct. So we'll say int sum is equal to 0. For int I is equal to 0, I is less than putts dot length, I plus plus. Now, reminder, what's length here? If you had to tell me everything you could tell me about length, what would you tell me? What kind of animal is that? I know what it does. It returns the number of elements in the array, correct? Well, at least the number of elements the array was built to hold. But what kind of animal is length? Okay, boils down to an int. That's not incorrect. Okay, keep going. Give me some more. Give you some options. Cat, dog, method, squirrel, field, hamster, constructor. Which one of those represents what length is here? Go ahead.
Field.
How do you know it's a field?
Well, there's no parentheses, it's not method or constructor.
So no opening, no parameter list, therefore you know it's not a method. And you know it's not a constructor. A, because there's no parentheses. B, because it seems like it's not matching the name of any class that we've heard of. But right off the bat, we know through process of elimination must be a field. Correct? Because, so basically this guy is a variable. It's an instance variable. How do we know it's an instance field? So he said why it's a field. Now the question is it an instance field or a class field? I'm telling you it's an instance field. How do we know that? Go ahead.
Because we're calling it with an instance of something with putts.
Yep, calling it with an instance of something, rather than some name of a class. We're pretty sure this is an instance because A, we see how it's defined up here, but B, it doesn't follow the naming convention for classes where it begins with a capital letter, which isn't required, but that tends to give us some evidence. Okay? So what are we going to do in here? We're just going to sum up all those elements. So sum plus equals putts at bucket I. Or you could say sum equals sum plus putts at bucket I. Okay. Then we're going to figure out where sum fits in makes. And once we find that, we'll get the corresponding handicap to set our handicap to it. Okay? So we need to spin through makes. So another for loop, same pattern. For int I equals 0, I is less than makes dot length, I plus plus. Each time through, we're going to ask, is the number of makes we're looking at equal to our sum? If it is, then our handicap is the corresponding bucket in the handicaps. If sum is equal to makes at bucket I, if that's a true statement, we have found the correct spot. And we're going to set this dot handicap equal to the handicaps at bucket I. And then we'll break. That make sense? Now, is there a guarantee from this for loop that handicap will get set from Java's perspective? From Java's perspective, there's two walls. First wall is, this is the for loop. For loops are pre-check loops. So there is no guarantee that the body of this for loop will ever get executed. The second wall is, here's an if statement. Even if we got into the for loop a million times, there's no guarantee we'll ever get inside this if statement. We know that if the person passes in putts in the correct format, that we will definitely get inside of this for loop as well as this if statement. But Java is not necessarily convinced of that. So what we'll do as a starting point is we'll set this dot handicap equal to our worst case scenario. Okay, which is the handicaps at bucket, the handicaps dot length minus 1. We'll write it generically like that in case at some point we come in here and we change our handicap scale. Then we don't have to change the code down here. Does that make sense? Okay, so again, we're seeing our problem-solving patterns. For loop here spins through all the buckets of the array called putts. For loop here spins through all the buckets of the array called makes. So all it does is take I on a journey through all the indexes of makes, just like this one takes I on a journey through all the indexes of putts. Okay, after this is done, the handicap should be set. Correct? Now, we want to go ahead and we need to, since this is a private variable, we want to be able to access the handicap. So we're going to go ahead and we're going to generate a getter for our handicap. So I'll right click on this. We'll go down to source, generate getters and setters, and we will select all getters. We don't need a setter. We don't want them to be able to set the handicap externally. We want it to just allow us to get that variable that was set. Hit OK, and there's our get handicap. Okay, nothing special about the method, just a method named get handicap returns an int, and it returns the handicap. So this is our start line. So we'll go and test this. Go into driver. Let's comment out this first little block here. So this was for something else. So we're going to say int array the putts is equal to, we'll follow what they had in theirs, even though we were expecting a different start line handicap. 0 followed by 5 ones. Right? Is that 10 of them? 5, 6, 7, 8, 9. No, one extra. I think they made the very last putt. Yep, so they missed 3 in a row. All right, so there's our putts. And we'll say start line, SL, is equal to a new start line, passing at the putts. This is our constructor. Constructors always come after the new keyword, right? Constructor did all of our setup for us in here. And then all we have to do is ask for the handicap. Start line dot get handicap. And this will hopefully give us, for this one, a -2. That's what we're expecting. And there's our -2. Make sense? Okay. Next one, short putting. We have 5 different length putts, and for each of those putts, we have 4 different types of putts. So we're representing all these values. How would we read in those values? How would we store those? Okay. Up to this point, we've always looked at single dimension arrays, right? I don't think we've ever looked at multi-dimensional arrays. $250, right? Okay, so when we create something like int array AR is equal to new int array 10, that creates for us a one-dimensional array with 10 buckets, each capable of holding an int. Correct? Done that a bunch of times. This is kind of our original data structure. Now, we are allowed to create multi-dimensional arrays. That is, for instance, a grid would be a 2-dimensional array, rows by columns. A 3-dimensional array would be a cube, rows by columns by depth, so X, Y, Z. After 3 dimensions, things stop making a lot of sense to human beings, but you could have more than 3-dimensional arrays. So I would say 2-dimensional arrays are relatively common. 3-dimensional arrays are going to be very situational. Beyond that, you may never see anything larger than that. In fact, there's a decent chance you'll never see a 3-dimensional array. All right, so we're going to look at things in terms of 2-dimensional arrays in here. So if I wanted to create a 2-dimensional array of integers, in this case, we'd probably have a 2-dimensional array of strings, right? Since we're storing some things like 0-R. So these data types would probably be strings. But if I'm creating a 2-dimensional array of integers, int array array, 2 square brackets, call this guy AR2, is equal to a new int array array, and we give it the size. This is rows by columns. So if I want this guy to be 3 rows and each row to have 4 columns, that's how we would define it. Now, just to show you something really quick, come out here to driver. We'll go ahead and comment out this code. And we're going to create an int array AR is equal to a new int array, what did I say, 3 by 4? All right, now, never rely on the default values. But in this case, I'm going to rely on the default values. Okay, but I'm just doing it to save a little time here. So the default value for an integer is typically 0. So we should get a bunch of zeros. But now I'm going to print out a couple of different things. I'm going to print out system.out.println AR at bucket 0. Now I'm going to print out system.out.println AR at bucket 0 at bucket 0. I'll also print out system.out.println rows colon is AR dot length. Calls is AR at bucket 0 dot length. Okay, and just for the sake of completeness, I'll print out AR up here. So I'm printing out several different things. I'm printing out just AR, and AR is an integer array, correct? So this should look like crazy memory address, because this is the pointer, correct? AR at bucket 0. At first glance, since this guy is an integer array, we might assume this would be an integer. This will actually also be a memory address. This will be a 0. This will be 3. This will be 4. And we'll talk about why here in a second. Memory address 0, 3, and 4. Okay? A two-dimensional array. So if we just replace multi with 2. A two-dimensional array is an array of arrays. Each bucket of our array is its own array. Okay? So our main array, AR, is a collection of rows. Just a single-dimensional array. Each element in our single-dimensional array is in itself an array with 4 buckets in it. Okay? So ultimately, this guy would look something like this. No, it ticks me off. Wait, hold on. Did I do 3 by 4? One would think those would line up, but perhaps not. Okay, whatever. And here's our magical non-existent pointer. All right, so AR points to the beginning of this array. So this is a single dimensional array. We have 3 rows, okay? But this array, each bucket was built not to hold an int, not to hold a char, not to hold a string. It was built to hold an array. It was built to hold an integer array. All right? So the value at each of these buckets will be an address. Okay? Because these guys are in and of themselves pointers to the beginning of the array that they represent. Our numbers will be in here. For example. Okay? So, if I say AR at bucket 0, that's going to this guy and going to his bucket 0. That guy's the memory address. And that's why when we printed out AR at bucket 0, we got a memory address. That makes sense? Because this is what's getting built in memory. When I said AR at bucket 0, 0, that takes me to this guy. That says, go to this array, go to his bucket 0. That's where I get my number. Okay? So, printing out just AR should go to the base address of this. Printing out AR bucket 0 should give me this address. Should these guys be the same? Hopefully you didn't notice when I printed them out. If I print out AR and AR at bucket 0, should they be the same value? This would be a good quiz, this question. What's this?
She's complaining. She has a free quiz.
So, question is, if I print out AR and I print out AR at bucket 0, will they print out the same address? Go ahead. Abe.
No.
Okay, why?
Because AR points to the other memory address. AR points to the AR at 0.
Okay. I'm not convinced yet. Tell me it more better. Well, more bestest. I'll take most bestest to begin with, actually. Let's not beat around the bush.
Because AR is a pointer that points to an array that points to different arrays.
Well, that's all true. So why will these guys print out different addresses?
Because they're in different places in memory.
Doesn't AR point to this guy, which is an address? Doesn't AR at bucket 0 point to this guy, which is an address? So why would they be different addresses? Isn't this address this address?
He points to the number 1, the next one.
Which does this guy?
Yes.
But so you're saying this guy won't even print out an address, he'll print out a 1.
No, I'm saying it prints out an address to the bucket that holds the 1.
Okay. So this guy,
Points to memory address points to that guy. And that guy holds memory address which points to a different guy.
okay. So if we print out these two values, we will be resolving AR. And AR resolves to its value. And AR's value is a memory address, right? And that memory address points here. It points there to the beginning of this array. When we print out AR at bucket 0, we'll print out that value. That is the value that lives at bucket 0 at this memory address. Remember the stuff we did last semester where it was AR, the base address plus 0 times size of, in this case it'll be int. Actually, in this case, it should be not size of int, size of address. So probably 32-bit, possibly 64-bit. So this is all going to boil down to an actual memory address. So our base address AR, let's just say that's memory address 100. 100 plus 0 times size of memory address will be what AR is. Well, that's actually AR at bucket 0. So if AR is memory address 100, okay, AR at bucket 0 will be the value that lives at memory address 100 plus 0 times size of address. So that comes out to 100 as well. The difference is AR's value is 100. AR at bucket 0 is the value that lives at memory address 100. That make sense? So AR is a variable that has a value, and its value in this little example is 100. This guy lives at memory address 100, but his value might be memory address 200. They should be different addresses, because this guy points to this array, which is what he was saying. So when we run this, we should see a different value for our first 2 lines. And also notice how Java handles their fake memory addresses. For arrays, AR is a 2-dimensional array of integers. So it does square bracket I, then at hexadecimal value for their memory location dealy flippy. What lives there is a 1-dimensional integer array, square bracket I. And what lives there is an integer. A bunch of integers. That make sense? So this is the structure of a 2-dimensional array. If we want to spin through a 2-dimensional array, so again, just for the sake of argument, allow me to assume this guy's already filled up with zeros. Okay? You know what? Let's fill it and then print it out. So we'll see the pattern twice. So I'm going to create an instance of a random object. We'll fill it with random numbers between 0 and 10. 0 and 9. Okay, so we're going to have to import java.util to get us random. Then we'll say for int I is equal to 0. I is less than ar.length. I plus plus. Then we're going to need another for loop inside this. So this outer for loop says for each row. The inner for loop is going to say for each column. So for int j is equal to 0. J is less than AR at bucket I dot length. J plus plus. And then we'll go ahead and give a value at that position. So we'll say AR at bucket I j is equal to r dot next int 10. So that'll generate a number between 0 and 9. So this is a pattern that will go through every bucket of AR, the whole grid, and fill it up with random numbers. Now to display it, we go through the exact same pattern. For int I is equal to 0, I is less than AR.length, I plus plus. Then we have another for loop. These are called nested for loops. For int j is equal to 0, j is less than AR at bucket I dot length, j plus plus. And then we'll say system.out.print AR at bucket I j. Then after we deal with all the columns, we'll do a system.out.println empty string. That'll kick us down a line. So we're prepared for the next row. So this should give us a grid displayed of random numbers. 3 by 4 grid. Three rows, 4 columns. Make sense? So these are the random numbers: 7439, 5501, 8263. All numbers between 0 and 9. Now, notice that right here, my inner loop is always rotating on AR at bucket I dot length. Would it be incorrect for me to say AR at bucket 0 dot length? Isn't the length of each of these arrays the same? The length of this array is 4. The length of this array is 4. The length of this array is 4. So isn't the length of AR at bucket 0 the same as AR at bucket 1, the same as AR at bucket 2? So the question is it incorrect for me to say AR at bucket 0 instead of AR at bucket I? Answer wisely.
Technically it works, but it's bad programming style.
Okay. Technically it works this time.
Yes.
Would it always work?
No.
Okay, how would we make it not work?
Could create this, instead of having Java create the arrays for you, you could manually create all the arrays.
So we can do this. We'll have Java go ahead and create the array for us, like we did. But let's just say, for the sake of argument, that we make bucket 2, well, bucket 1, the center row. AR at bucket 1 is actually a new integer array of size 10 instead of size 4. So we changed the memory address. We overwrote the value that used to live at AR at bucket 1 with a brand new integer array. This integer array has 10 buckets in it. So now what we just did is we made this center guy that. Does that make sense? AR at bucket 0, 1, 2, so AR bucket 1, we're going to overwrite this value with a new memory address. The memory address by creating a brand new array. This array is a 10 bucket array. So we originally created it as a 3 by 4 two-dimensional array, correct? So all the rows had four bucket arrays in them. But then I hijacked bucket 1 and said, you know what? Overwrite the value in bucket 1 with a new integer array of size 10. Does that make sense? So now it is very important that I use I instead of 0. Because if I leave it as 0, I'm going to print out a 4 by 4 grid or a 3 by 4 grid. When really the second row should have 10 elements in it. So when I display this, if I have this displayed as 0, AR at bucket 0 dot length, then my length will always be assumed. The length of each row will be assumed to be 4, even though row 1 actually has a length of 10. So we'll see we still get 4 by 4 grid. But if we change this to I and then run it, we see that that middle row is actually longer. Does that make sense? Now, is there a real need for something like this? Short answer is maybe. Longer answer is probably with objects, no. Historically, before we had object-oriented languages, we might have decided to store different types of values inside of a two-dimensional array. Bucket 0 has one value in it. Bucket 2 has another value in it. Bucket 3 has another value in it. But if those values happen to be arrays or collections of information, we might need different numbers of those things. So we would create a multi-dimensional array with different sizes in each bucket. Now, the question here is there any other way for me to create this phenomena? Is it phenomena or phenomenon? This magic trick without first creating a two-dimensional array like this and then hijacking one of the buckets. AR is an array with 3 elements in it, and each bucket of that array is capable of holding an integer array. Can I make a one-dimensional array of integer arrays? A one-dimensional array of ints looks like this. Int array blah is equal to new int array 5. How would I make an array of int arrays? This is going to give us some information about how Java is actually built. If I want an array of int arrays, I would, instead of an array of ints, I would replace int here with int array, correct? So this guy right here is an array of ints, but I want an array of int arrays. So this is my type, this is my type. So if I want an array of int arrays, I will replace just the word int with int array. I'll replace just the word int with int array. That makes sense? But am I allowed to leave that guy blank? This guy is the number of elements in blah. This is my rows. This is my cols. Correct? Let's say that I want to have 5 rows, but I might want to have a different number of columns in each of those rows. Can I leave that blank? I did not give it a second value. Let me comment out all this stuff down here. So if I loop through, and I print out blah at bucket I, what will print out? Blah will have a memory address, that is the memory address which points to the B. So this is blah. Blah will have a value, which is the memory address which points to the beginning of the array. But if I print out blah at bucket I, what value will it print out here? If when I built this guy, I did not give it a number of columns. What do you think will print out? Nothing. Null. Null means the empty address. This is capable of holding an address, but currently does not. Why does it not hold an address? Since we did not provide a number of buckets here, Java's creation procedure for creating a two-dimensional array did not go ahead and instantiate the arrays in each of these buckets. It didn't create them for us because we didn't tell it how long they should be, because we intend to make them different lengths, potentially. Does that make sense? If we had changed this to 2, we would get a bunch of memory addresses now, because it went ahead and created 2 bucket integer arrays at each of those places for us. So what it did for us is equivalent to this. If I take that out, it did blah at bucket I is equal to a new integer array of size 2. It went ahead and gave bucket I its value. Its value is a memory address because it's on the receiving end of the new keyword. Does that make sense? New keyword always boils down to a memory address. So now I'm giving it the value there manually rather than letting Java do it for us. So rather than putting a 2 here and letting Java do all the work, we're leaving that blank and we're doing the work right here. We're putting the 2-dimensional array, or the 2-bucket integer array in there for us. Then we'll print out I and we'll get the memory address. Make sense? There's an awful lot of memory addresses being flown around for a language that doesn't have memory addresses. Okay, so for a 2-dimensional array, we work things that way. Now, in this case, we have 5 rows by 4 columns. Do we need to do our magical, let's do this as a single-dimensional array and then add arrays in there each time? Or can we let Java do all the work for us? Are all of these columns the same number of columns? Each row has the same number of columns, correct? So we can let Java do the heavy lifting for us. So this is a 2-dimensional array of strings where we have 5 rows and we have 4 columns. And this guy is for short putting. So we're going to create a short putting object. Okay? And short putting is going to give us a handicap based on this breakdown. So all we're going to have again at the top level is handicap. Private int handicap. And we'll have our public short putting. This guy is going to take in a what as a parameter? Two-dimensional array filled up with strings. So right now we're putting a lot of heavy lifting on the end user. So more than likely what we're going to do is we're going to take all these objects and we're going to put them inside of a class. What's the name of this thing? Well, whatever. It was called, put it inside of a Seymour class or something like that. That does the asking the user, prompt them, please set up for a 4-foot putt. Did the first one miss? Did the second one miss? The third one? And it will do the work of putting it into the right format that this guy needs. Okay? So we are not going to expect our end user to create a 2-dimensional string array. We won't expect our end user to create a 2-dimensional string array, but this guy is going to take in a 2-dimensional string array. If we did not want to do it as a 2-dimensional string array, what would be an alternative? What would be a more object-oriented alternative? So we're kind of seeing the evolution of arrays to objects here. So if this is our data, that we're initially thinking about storing as a two-dimensional string array? What could we do? Instead of a two-dimensional array. Could create a linked list. Okay. Why would a linked list be a bad idea?
You have to run through the entire list to get a value.
No, that's always a bad idea with linked lists. I mean, that's always the downside to linked lists. So it's not an incorrect statement. But in this particular case, why is the linked list not the correct tool for the job? Let's take it a step further. A linked list of what? What do you want to store at each bucket of the linked list? What is each element? So what is each node's payload?
Oh, we're using strings, right?
Yep. So don't say string.
Well, yeah.
I guess if you really want to get creepy here, you could say, well, it's a linked list, and the payload at each element is a linked list. Rows by columns, right? So you could build a two-dimensional array by creating a two-dimensional linked list. It's a linked list of linked lists. Well, if we're going to do that, we might as well do arrays. Why? Same answer I'm looking for from you from the first why I asked. Why is a two-dimensional array better than a linked list of linked lists? Why is an array of arrays better than a linked list of linked lists?
An array is easier to make.
That's, well, using Java's built-in linked list, that's not necessarily true, but it might be. It might be a little easier to make. I'll give you half a point on that one. But why is a linked list not the best tool for this job? What's the benefit of a linked list? It's memory efficient, fine. It's slow to traverse, fine. But we need to use linked lists when our data has a certain property. And what's that property?
Unknown size.
Unknown size. We need to store an arbitrary number of elements. We use linked lists rather than arrays where we have to keep knocking down the house to add on a room. Right? Remember that example we used? If we have a 4-bucket array and we need to add a 5th bucket, we don't just add a 5th bucket. We destroy the 4-bucket array, but before we do that, we copy everything over. We mimic it, but we add the extra room on the side. So it's like building a brand new house with 1 extra room, moving all your crap into the new house, and then destroying the old house. Never do that in real life unless you're like Donald Trump or something. Okay? So in this case, we do not have an arbitrary amount of data. We know exactly how much data we have. Now, if we know exactly how much data we have, I want to make sure I'm not going to, oh, let me throw this question out and we'll come back to it on Tuesday. If we know exactly how much data we have, is there ever a situation where we'd still use a linked list? The answer is yes, if we have a lot of data. Then we need to start thinking about memory. Okay? All right, we'll stop there. No homework. Remember, we got the computer science get-together right down the hall here at 11:30. At 11:30 sharp, we'll be starting our little game, so make sure you go run to the bathroom or whatever, but get down there right on time because the best prizes go to the people who win win that meet and greet game. Okay? I'll see everybody in a few minutes.